Now let's look at the sequence and cycles of the stages. You are awake, so let's start up here. You are awake. You progress down through N1, N2, N3. You hang out here for a while and you're coming back up. Then to N2. And look at, instead of N1, you go into REM sleep. Note that a typical sleep period involves 5 of these rotations at about 90 to 100 minutes each. Note the red REM periods. What's happening as the night progresses? You're getting longer, right? In fact, you tend to spend about 50% of the last half of the night in REMS. This is why men so often wake up with an erection. That, by the way, is called nocturnal penile tumescence, because the erection appears in REM and generally outlasts REM by up to 20 minutes. Note that almost all your deep sleep, N3, okay, happens pretty early at night in the first half. So SWS, slow wave sleep, is finished about halfway through. REM is very brief early on, and then is far more significant in the second half. This means that N2 here, okay, takes up the biggest slice of your sleep pie. In fact, you spend about 50% of a total typical night in N2 sleep, and the other 50 split up between the other stages. Note that you are most likely to wake up naturally after this REM period. Note that if an alarm wakes you up in the morning, it is more likely that it will be right after or during REM than earlier in the night. Now, there is a very fuzzy line between being drowsy and being in N1 sleep. When researchers awakened sleepers during N1 in the sleep lab and asked if they were sleeping lightly or just drowsy, sleepers cannot usually guess better than chance. When do you think this is especially dangerous? When driving or operating heavy machinery, right? Performance is clearly hurt in these and other complex tasks when we are drowsy. In fact, performance is so degraded that it is even a significant difference in very simple tasks. Ogilvy in 1989 had sleepy participants perform very simple tasks during their transition from drowsy to N1. For instance, he had some tapping alternative fingers, that's it. Others simply pressing a button each time they heard a sound. So simple that, when awake, they performed at nearly 100%. But as they became drowsy, reaction times were significantly increased, though their accuracy still remained high. But both the reaction times and accuracy dropped dramatically by 60 to 75% when moving into N1. By the way, nicknames of studies will always appear on the slide along with the researcher's name spelling. So if you look back at this last slide, Ogilvy's simple task study, you will want to know the major finding or findings of the studies and be able to match the researchers' names in this class. You do not need to memorize the year of studies, except for the history section earlier in this lecture, when researchers' findings were listed by year and appeared right on your slide. Okay, more terms. A sleep period begins when you first fall asleep at night and proceeds until the last time you awaken. This is a cool little word, nikthymeron, that refers to the 24-hour period of a day and a night. It is used often to avoid the ambiguity of saying one day when you are actually referring to 1 day and 1 night. Sleep efficiency refers to the proportion of a sleep period that you actually spent asleep. Sleep onset occurs when you pass from drowsy to N1. And sleep latency refers to how long it takes for you to reach sleep onset. In our next segment, we'll look at what age has got to do with it.